You've just finished typing an email. It could be homework for your teacher, a funny picture for your friend, or a note to your grandparents halfway across the world. You move your mouse, click the send button, and whoosh, it's gone. A few seconds later, your friend's phone buzzes. They have your message. It seems like magic, like your words teleported from your screen to theirs instantly. But what really happens in those few seconds? The journey of that email is one of the most incredible high-speed trips on the planet. It's a story about breaking things apart, finding a secret address, and navigating a global maze of light-speed traffic. Let's go back to that moment you press send. Your computer doesn't just send the whole email in one big chunk. Imagine trying to send an entire book through a tiny mail slot all at once. It wouldn't work very well. Instead, your computer, using a set of rules called the Transmission Control Protocol, or TCP, acts like a super fast paper shredder. But instead of destroying your message, it carefully chops it up into hundreds or even thousands of tiny, equal-sized pieces. These tiny pieces are called data packets. Each packet is like a single postcard. It contains a small part of your message, but it also carries some very important information written on it. Think about sending a puzzle to a friend. You wouldn't just dump all the pieces in a box. You would number them so your friend could put them back together. Data packets are the same. Each packet gets a digital label. This label says which email it belongs to, what number it is in the sequence, and most importantly, where it's going. Now your message is broken into tiny, numbered, addressed postcards. But where exactly is it going? You typed your friend's email address, like friend@emailservice.com. Your computer doesn't understand that. Computers only understand numbers. Specifically, they need an IP address. An IP address is a unique string of numbers that acts like a specific street address for every single device connected to the internet, including the giant computers that handle email. So, your computer needs to translate emailservice.com into a numerical IP address. To do this, it asks for help from something called the Domain Name System, or DNS. The DNS is the Internet's giant phone book. It's a massive, distributed database that contains millions of entries. When your computer asks, what's the IP address for emailservice.com, the DNS looks it up and sends back the correct number. Now your packets have everything they need. They have a piece of your message, a sequence number, your return address, and the final IP address of the destination. They are ready for their journey. The journey begins at your Wi-Fi router or the cable plugged into your computer. This is the first stop, like the local post office for your data packets. Your router's job is to send them on the first leg of their trip. From here, the packets travel out into the vast, complex network of the internet. They are passed from one specialized computer to another. These special computers are called routers. You can think of these routers as the internet's traffic police. There are millions of them all over the world, and their only job is to look at the address on each packet and decide the fastest, most efficient way to send it to the next router. A router doesn't know the full path. It just knows the best next step. It's like asking for directions in a huge city, where each person you ask can only point you to the next street corner. Now here's where it gets even more amazing. Not all of your packets will take the same path. Remember, routers are always looking for the fastest route at that exact millisecond. If one path is too busy with other data traffic, a router might send some of your packets on a completely different route. One packet might travel through Chicago, while another might go through Atlanta. Some packets containing your single email could travel through different cities or even different countries on their way to the same destination. How do they travel? They travel as pulses of light. Most of the internet's backbone is a massive network of fiber optic cables. These are tiny strands of glass as thin as a human hair. Your data packets are converted into flashes of light that race through these glass cables at, quite literally, the speed of light. These cables run under our streets, across countries, and even lie on the bottom of the ocean floor, connecting continents. Your email is likely crossing an ocean as a flicker of light in the submarine cable. This entire process of a packet hopping from one router to the next takes only a few milliseconds. A millisecond is a thousandth of a second. It's faster than you can blink. Eventually, after hopping across dozens of routers and traveling thousands of miles, the packets start to arrive at their destination, the email server for emailservice.com. But remember, they traveled on different paths and might arrive out of order. Packet number 77 might arrive before packet number 12. This is where those sequence numbers become critical. The destination server is like a mailroom sorting clerk. It gathers all the incoming packets that belong to your email. It looks at the sequence number on each one and begins to reassemble them in the correct order, just like putting a puzzle together. It also checks to make sure every single packet arrived. If a packet gets lost or corrupted along the way, the server sends a message all the way back to your computer asking it to send that specific packet again. This is a self-correcting system. It ensures that the final message is absolutely perfect and complete, with no missing pieces. Once all the packets have been received, checked, and put back in the right order, your original email is perfectly reconstructed on the server. The job is almost done. The email server now knows the message is for your friend. It places the complete, reassembled email into your friend's personal mailbox on that server. The email now just sits there, waiting. It's no longer traveling. Its journey across the world is over. The final step happens when your friend opens their email app on their phone or computer. Their device sends a signal to the server saying, "Hey, is there any new mail for me?" The server responds, "Yes, you have a new message from," and it sends a copy of your email down to your friend's device. And that's when their screen buzzes, and they see your message appear. From your send click to their screen, a mind-bogglingly complex journey took place. Your message was deconstructed into tiny pieces. Its destination address was found in a global phone book. Those pieces traveled as pulses of light across cities and oceans, guided by millions of traffic cops. And finally, they were all perfectly reassembled at the destination, all in the time it takes to snap your fingers. This doesn't just happen for email. It happens for every website you visit, every video you watch, and every message you send. The big insight here is that the internet is not a cloud. It's not a magical, invisible force. It is a real, physical thing. It's a collection of hundreds of millions of computers, routers, and servers, all connected by a web of glass cables and radio waves that stretches across the entire globe. Every time you go online, you are using one of the largest and most complex machines humanity has ever built. It's a system built on simple rules and protocols that allow for unbelievable speed and reliability, all working in the background, completely hidden from view. So the next time you write a message, attach a photo, and get ready to click that send button, take a moment to think about the journey it's about to take. It's not teleportation. It's technology. It's a masterpiece of engineering and computer science, performing an incredible feat of global delivery just for you. It's the hidden, high-speed world that powers our modern lives, all starting with a single click.